Okay, so in this video what I'm going to do is hook up the L293 motor driver and a couple of small motors so we can test it out, make sure it's working. We'll also take advantage of this power supply being here. We'll test the power supply and make sure it actually can run things when the cable has been disconnected. So we're going to take our first sort of autonomous testing. So to do this, we need to first understand a little bit about the L293 motor driver and how it's hooked up. And you can see here's a diagram of the chip itself. There's going to be a fair number of inputs. So it drives two motors. Okay, you can actually use it to run a stepper motor as well, but we're going to be using it to run two DC motors. And our DC motors are going to be hooked up here to output 1, 2, 3, and 4. With one motor being on 1 and 2 and the second motor being on 3 and 4. Enable pins, they are set high if you want it to run, turn it on or turn it off. And at some point we'll set up a piece of code that's going to pulse this enable pin so we'll be able to do various speeds. So we pulse it, hook it to a pulse width pin, and we'll be able to pulse it fast if we want the motor to go fast, or we'll pulse it slowly if we want the motor to go more slowly. Inputs 1, 2, 3, and 4. Inputs 1 and 2 control outputs 1 and 2. So inputs 1 and 2 essentially run the motor hooked up to this side. And essentially it's a very simple logic. If you have input 1 high, for example, and input 2 low, that means the polarity is going to be such that the motor will spin either clockwise or counterclockwise. We have to sort of figure that out experimentally. But it's going to have one particular polarity. If I flip that so that this one is low and this one is high, then the polarity is going to flip between these two pins and we'll be able to switch the direction of the motor. Okay? All the center pins are grounded. It takes a lot of current and it takes 4 grounds. In fact, you can actually hook up a heat sink to these as well to dissipate some of the heat. The L293 will get hot, especially under load, and if you stall the motor, it's possible you could burn it out. So we do got to be careful about that. In other words, you don't want to hold the wheel while the motor is on. Okay, so with this little piece of information, we'll bounce back to this here in a second. I'm going to go ahead and place my L293. Again, keep an eye out for that notch. I'm going to put mine here across the center. Okay, so I've plugged it in between 40 and what is that, 33, something like that. And I've actually already made a number of staple wires that make this super easy on me. Now you probably don't have to watch it all, but I'm going to go ahead and put the ground ones in the center. Okay, remember all 4 of these center pins are grounded. I'll put 2 over here, like so. Make sure that I actually, oh yep, I got it. Momentarily worried that I plugged it into a positive. Alright. Okay, so I've got all 4 of the center pins grounded. Let's bounce back to that diagram real quick. And like I said, for the moment we're just going to run it on and off. We're not going to worry so much about speed. So I want to have all of these pins. I want the enable set to high, so I want to hook it to the power. I want VS, this is the voltage that would drive the motors directly. I'm going to set that to the power bus. I want enable to set to the power bus. I'm going to run everything on 5 volts in this experiment, in this robot, so don't have to worry about separating them. And I'm going to have VSS on power. So everything is going to be running on 5 volts. If I wanted to run the motor faster, I could put this on its own separate power. So I could put this at like 7 volts or something like that, make it much, much faster. But I would not want to run any of these other pins, these 3 pins at 7 volts. This is the only one that I can vary the voltage to and have it hooked up independently. So let's go back, and I'm going to do exactly that. So I'm going to hook up, for example, this one to power. And that's the one that drives the motors directly. I'm going to set the enable pin here high by hooking it to power. Come on. Okay. So now I made enable 1 is hooked to power. I'm going to power the chip itself. And last but not least, I'm going to hook up enable 2 to power. So now both enables are hooked to power, the motors are hooked to power, and the chip itself is hooked to power. All the sensor is grounded. Okay? And the next thing we're going to do, oh, I should jump over here. Hold on one second. Let's take a look again. Like I said, ultimately, at some point, we may want to pulse these motors to set their speed. To do that, we want to use PWM pins. To set them high or low, just to switch the direction, they can be digital pins. So I'm going to use actually 7, 8, 11, and 12 to set the directions. Okay? And I'm going to keep 9 and 10 free for the moment so that if I want to do a pulse width modulation, I can. So I'm going to use 7, 8, 11, and 12 as my driver pins. So that being said, I'm going to take a length of this wire here with male ends on both sides, and I'll just hook it up simply like this. So I'm going to hook the orange and yellow, in my case, to pins 11 and 12, and I'm going to skip the next 2 pins, so 9 and 10 are skipped, and I've hooked up the brown and red, in my case, to pins 7 and 8. I want to remember this side of the chip controls one motor, this side of the chip controls another. So I'm going to take the 2 inputs quickly here. I'm going to take these 2 inputs and hook it to pins 11 and 12, and I'm going to hook these 2 inputs to 7 and 8. Okay, so let's do that. I'm going to make this 11 and 12. I think I'll put 12 down here. I'm going to put 11 up here, and I'm going to do the same thing here, 7 and 8. And last but not least, the motors themselves. And again, we have to do this experimentally. I can't tell you which way it needs to go to make the motor turn clockwise or counterclockwise. So I'm simply going to plug it in to those remaining spots on either side of ground, like so. And there we go. Now we've got the 2 motors and the L293 motor driver connected. Let me go ahead and find a piece of code or write a piece of code, and we'll play with this for a second. I'll be right back. Okay, so I'm ready to test this out. I've written a really simple piece of code. The first thing that I did is I created 2 variables, in 1A and in 1B, referring to the 2 input pins on this side, which will ultimately control this motor. I set both of those pins to outputs so that I can set in a signal high or low. And let's go ahead and give it just a test. I don't really know which direction it's going to go. So for 1 second, I'm going to set A high and B low. And then for the next second, I'll wait 1 second, and then for the next 1,000 milliseconds, I'm going to set pin A low and B high. So what we should see when this loads is the motor spin one direction, then switch directions on 1 second intervals. Keep in mind, I do not have a battery yet hooked up to this. I am running it strictly off the 5-volt USB. So that might be a little weak depending on your computer supply. But let's give it a whirl and see what happens. I think it's going to work on mine, but oftentimes laptops it does not. And sure enough, you can see that it spins one direction for a second and then the other direction. If I hook up power to it, it'll probably give it more, although not too much more. I'm sort of surprised. It gives it a little more zip, but not significantly. So it's already running at pretty much max speed. Let me go ahead and get another motor running, and we can watch them both go and see how this actually works. I'll be right back. Okay, so you can see I've added some more lines of code. I've just basically copy and pasted stuff. I copy and pasted these 2 lines we had from the last code, pasted it here, added a 2. Okay, so I'm going to refer to this side of the chip. This is going to be side 1, this is going to be side 2. I set those pins as well to output. Okay, so I'm hooked up to 7, 8, 11, and 12, skipping 9 and 10 because those are PWM pins. We might use those for speed control. And then I copy and pasted these sets of lines right here. So I'm just going to be turning on the second side alternately as well. So I'm going to set one high and one low, wait a second, and then set it low and then high. So what we should see is both motors go. And there they go, both running, switching directions. And if everything goes right, I should be able to untether this. And it continues to run because it's now being provided power by this battery pack through this supply here. And we're going to test it. If I turn that off, everything stops. Turn it back on. The code begins to run, and we're ready to go. So I'm going to plug this back in so we can do some more coding. I'm going to show you a little trick here that I did so that I didn't have to listen to these motors. If I take and select all of this, I can hit Control/ on the keyboard and it comments them all out. And I've secretly hidden a little piece of code down here. If I set them both to low, it'll turn all the motors off. So I'm going to run this again. This is commented out. I'm going to run this again, and you're going to see that when it runs, lows, all the pins are set to low, and the motors do not run. So I think I'm going to end this one, and then we'll continue to build here in a moment.